Hello everyone. Now we'll be looking at the third lesson of this course regarding data types. What are data types? Variables that we learned about in the last class are grouped into different data types. Data types give different properties to variables. Here are a few examples. You have the integer data type, the float data type, and the char data type. Integers are examples like 1, 0, -4. These are all the integers that you've learned about in maths. Float data types are numbers that involve decimals. Char data types have are normally single character but can even be multi-character in some languages. These can include letters and even numbers. There's also the string data type that can contain words or even sentences like AB or I love coding. An important thing to notice is that we use single quotes for characters and double quotes to denote strings. There's also one more data type called the Boolean data type. It might sound strange, but these are a kind of variables that can only take two values, true or false. They are used with logical operators, which will be explained later. Why do we use data types? Data types help us understand 1. What is required from each variable, and 2. How they will be used in the program. These points are quite closely related. Now, for an example, let's say I declare an integer a. Then it's clear to whoever's reading the program that a will be a number which I can use arithmetic operators on. If I declare a string b, then it's clear that b might be a word or any collection of characters, and I won't be using b in arithmetic operations. So obviously, if I try a into b, it'll give me an error because both data types are not the same, and it won't make sense if we do the above operation. In some languages, in other languages, it might be possible. They might consider the multiplication of a number in string to mean repeating a string many times. But for most languages, you cannot multiply an integer and a string. Now, before we can use a variable, we have to tell the program that they exist. This is done by declaring them. We can also give it an initial value if we want to, called the initialization of the variable, as has been done in the examples below. So here, as you can see, I have declared a variable a of integer type and initialized it with the value 1. Here I've declared a variable b of float type and initialized it with the value of 1.00. Similarly, for c, char c and string d, keep in mind here, remember we use single quotes for characters and double quotes for strings. All of these variables might seem like they have similar values, but they are all different data types and can be used in different ways. Now let's look at arithmetic operators. Here we have all the usual arithmetic operators that we've been familiar with for a long time, and we also have the modulus operator, which I've explained in the last class. Let's talk a little bit more about how data types are affected by arithmetic operators. If there are only integer types involved in an expression, the program will force the answer to be an integer. So 6 divided by 3 will of course return 2. All are integers. If a single float value is involved, the expression will return a float. So here I've written that 6 divided by 3.0 will be equal to 2.0. Since there's a float value involved in the expression will return a float. Let's look at some interesting consequences about what happens because of this. So as you can see, any operation performed between integers will return an integer, and any operation performed including even one float will result in a float. Even if so here's an example. If I declare an integer a equal to 10, a float b equal to 5.00, and I add them up, it will return 15.00, which is another float value. An interesting example would be here. If I have declared an integer a equal to 25 and integer b equal to 2, 6 plus a by 5 into b is equal to 16. That is pretty clear. 6 plus 25 by 5 into 2 will be equal to 6 plus 5 into 2, which will be equal to 6 plus 10, which is equal to 16. However, the interesting thing to see here is if I try a divided by b into b equal to 24, what will I get? I'll get 25 by 2 into 2. 25 by 2 is 12.5, but like I said before, an expression involving only integers will return an integer. So the program will change this 12.5, it will ignore this 0.5 and consider only the 12. Thus, 12 into 2 will give me 24. The same thing done with floats would give me the usual answer. C divided by d into d, where C is 25.0 and D is 2.0. Like before, A was 25 and B was 2. Now C is 25.0 and D is 2.0. So now, if I do the same expression, calculate the same expression C divided by D into D, it will return 25.0 instead of 24. Why? Because this time 25.0 divided by 2.0 can give me 12.5. The program will not force the answer to be an integer. Let's talk about logical operators. Logical operators always return Boolean values, true or false. These are some of the commonly used ones. We have less than, greater than, less than, equal to, greater than, equal to, the normal equal to, and not equal to. We have two more logical operators, the AND operator along with the OR operator. We'll understand the uses of all these operators through examples. Here we have different logical operators and the possible data types of the variables p and q. For the equal to or not equal to logical operator, p and q can be any data type, int, float, string, bool. For the AND condition or along with the OR condition, p and q have to be Boolean values. If we use greater than, less than, or any of these, then p and q can be integer or float values. Of course, here we cannot use string or char because that would not make sense. One string cannot be greater than the other. The length of one string could be greater than the length of another string, but in that case, the length would be an integer. All logical expressions, these are all called logical expressions, and all logical expressions return Boolean values.
To learn these concepts hands-on through fun and exciting games, visit thinkverse.in and start learning now.